Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about foundation engineering load-bearing piles. Load-bearing piles. Cast iron piles. Cast iron piles are hollow tubes of cast iron having inner diameter 20 to 40 cm and wall thickness 20 to 30 mm. These are generally 4 meter in length, and for longer lengths these are joined by a suitable device. Cast iron being a brittle material, these piles are provided with helical screw at the lower end, and the whole assembly is rotated to drive the pile inside the soil. Piles with helical screws are generally known as screw piles. Cast iron piles are suitable for shallow foundations and are suitably employed for the foundation of marine structures, lightweight bridges and buoys anchors. Cement concrete piles. These are of the following types. Cast in situ piles. These piles are cast with cement concrete at the place where these have to carry superimposed load. For casting the pile, a hole is driven by excavating with an auger or driving a casing. The hole is then filled up with cement concrete. As these piles are generally driven vertically, no reinforcement is needed. If the casing is left in position, the pile is known as cased cast in situ concrete pile, and if the case is withdrawn, the pile is known as uncased cast in situ pile. Uncased cast in situ concrete piles. Uncased cast in situ piles are used where the ground does not disturb the pile hole with soil or water falling in it. They are cheaper than the cased piles but not as much as efficient than cased piles. Skilled workers are required to install uncased cast in situ piles. The main disadvantage with these piles is no inspection is possible after the installation. The advantages are storage space is not required and special equipment is not needed. Types of uncased cast in situ concrete piles. Following are the different types of uncased cast in situ concrete piles and their uses. Simplex pile, Franke pile, Vibro pile, Pedestal pile. Simplex pile. Simplex pile is useful for both soft and hard soils. To obtain simplex pile, a steel tube with cast iron shoe is driven into the ground up to desired depth. After that, reinforcement is provided in the tube and then filled it with concrete. Then, the tube is slowly removed and cast iron shoe is left at the bottom. So, for each pile new cast iron shoe should be attached. To overcome this, cast iron shoe with alligator jaw point is provided. Due to this jaw point, the shoe can be removed along with tube. The soil must be able to hold fresh concrete after removing tube. Frankie pile. Frankie pile is suitable for granular type of soils and for soils bearing stratum of limited thickness is located at reasonable depth. This type of pile has mushroom-shaped bottom which acts like spread footing. To construct a Frankie pile, initially a pipe shell consisting concrete or gravel at bottom is placed on the ground with the help of leads. Next, a drop hammer of 20 to 30 knots weight is dropped using diesel machines on the concrete bottom. Then the whole arrangement is driven into the ground. After reaching hard strata, the concrete bottom expands and gains mushroom-like shape due to hammer blows. After that, some proportion of concrete is placed in the tube and ramming is done with hammer. Similarly, ramming is done for every 300 mm layer up to the top. If reinforcement is to be provided, then the hammer goes inside the reinforcement cage. Frankie piles can carry up to 900 knots. Pedestal pile. Pedestal pile also featured same as Frankie pile. It is also suitable for soils containing limited thickness bearing stratum at reasonable depth. Pedestal piles also acts as spread footings. But in this case, steel core is used inside the tube for driving. After driven to the required level, the core part is taken out and is filled with some amount of concrete. Then, replace the core on the concrete and remove the whole tube and core suddenly with some pressure. This allows the concrete at bottom to expand and forms bulb-like shape. This bulb is called as pedestal. Repeat the process until the top is reached. Finally, tube and core are removed and pedestal pile is finished. Pressure pile. A pile which is made by pouring cement concrete inside a casing pipe in layer of 30 cm, and each layer being compacted by compressed air is called a pressure pile. The casing is gradually lifted. Such piles can resist shocks and vibrations to greater extent. Vibro pile. Vibro piles are suitable for soft soils which offers some amount of frictional resistance. Two different vibro piles are: standard vibro pile, expanded vibro pile. Standard vibro pile. Standard vibro pile contains same diameter all over the length. To install this, a steel tube attached with cast iron shoe is taken and driven into the ground. The driving is done by mechanical hammer of 20 to 25 kN weight. It blows from a stroke of 1.4 meter height at a rate of 40 blows per minute. After reaching required depth, the tube and hammer are attached to extracting links. Concrete is poured into the tube from top and ramming is done by hammer at a rate of 80 blows per minute. While the concrete is filling, the tube moves upwards. The cast iron shoe remains at bottom of the pile in this case. Vibro piles can be installed in 35, 45, and 50 cm diameters up to a length of 25 meters and for loads of 600 to 700 kN. Expanded Vibro pile. Expanded Vibro piles are used when the depth of driving is limited or less than the required depth. In this case, the bearing capacity of soil can be increased by expanding the diameter of Vibro pile. A steel tube fitted with cast iron shoe is driven into the ground. After reaching depth, the tube is filled with concrete up to some depth and tube is completely removed. Now flat shoe is attached to the bottom of tube and inserted in pile hole. This flat shoe makes contact with concrete and pushes it hardly. The concrete will be compressed and bulged or expanded like bulb shape. The tube with flat shoe penetrates concrete and forms deep hole in which reinforcement cage is inserted, and finally this whole arrangement is filled with concrete after removing the tube. Expanded Vibro piles are finished finally. Under-reamed pile in soils which experience alternate swelling and shrinkage due to changes in its moisture content. Under-reamed piles are used for transferring heavy loads. Under-reams are provided at distance 1.5 meter apart. Cased cast in situ concrete piles. Cased piles consist a shell around it, and these piles when casted inside are called cased cast in situ concrete piles. In case of cased cast in situ piles, the shell is usually made of steel. This type of piles is suitable for any types of soils. Advantages of cased cast in situ concrete piles. Main advantages of cased cast in situ piles are as follows. The shell has driving resistance, so it can be easily driven. Concrete filling is not disturbed. Internal inspection can be done after driving shell. Piles can be easily cut or extended in case of cased piles. Types of cased cast in situ concrete piles and uses. Different types of cased cast in situ concrete piles are Raymond piles, MacArthur piles, Union metal monotube pile, Swage pile, Western button bottom pile, Raymond piles. Raymond piles are economical piles of cast in situ piles which are developed by A.A. Raymond in 1897. There are two types of Raymond piles are available, namely Standard Raymond pile, Step taper Raymond pile, Standard Raymond pile. Standard Raymond pile is used as friction pile because of its heavy taper of 1 in 30. Diameter of Raymond pile gradually decreases from top to bottom. At the top 40 to 60 centimeters and at the bottom it varies from 20 to 30 centimeters. The length of Raymond piles varies between 6 to 12 meters. The Raymond pile contains corrugated steel shell which is closed at the bottom and is reinforced with wire. Wire is wounded spirally around the shell with 8 cm pitch. The shell is driven into the ground by placing core or mandrel in it. After reaching required depth, mandrel part is removed and is filled with concrete. Step taper Raymond pile. In this case of step taper Raymond pile, the pile consists series of shells, which are placed one above the other. But each shell is of different size, i.e. shell size is gradually increased from bottom to top. To ease driving, bottom shell should be made of heavier gauge and closed at bottom. Then next shell section is placed on it. The connection between steel shells are done by the screw connections. Usually 2.5 centimeters increase in diameter is provided for shells with respect to their bottom one. Also, steel mandrel or core is used to driven the shell sections. Step taper random piles can be driven up to 36 m of depth. This type of pile can be useful as friction pile as well as end-bearing pile. The advantage compared to standard random pile is that it can be inspected easily, fresh concrete can be filled and length flexibility. MacArthur piles. MacArthur piles generally in uniform diameter and shell is made of corrugated steel. But driving is done by the combination of steel casing of heavy gauge consisting core. After driven to required depth, the core is removed and corrugated steel shell is inserted in heavy gauge steel casing. Then, concrete is filled in the corrugated steel shell and outer hard casing is removed. Union metal monotube pile. Union metal monotube piles consists only shell without any mandrel. The shell is made of steel and is tapered fluted. These types of piles are well suitable for most of the soil conditions, that is from end-bearing to friction load-carrying soils. The shell is more rigid and watertight, and this shell can be driven to larger depth using hammer. After driving, inspection is done and then concrete is filled in the shell. Swage pile. Swage piles are widely used in case of hard soils. Precast concrete plug is attached at bottom of shell to drive the pile shell. Steel core is inserted in shell and driven, and then shell is swaged out by the taper of the plug and form watertight joint. Next, the whole arrangement is driven into the ground to a required depth. After reaching desired depth, core is taken out and the pipe or shell is filled with concrete. Western button bottom pile. Western button bottom piles are widely used in end-bearing soils. The pile consists a concrete button at the bottom which helps the pile to drive into ground. This concrete button is wider, about 25 mm diameter, and sharp at bottom, so it makes wider hole and eliminates side friction. Initially, the steel pipe with 12 mm thick wall is placed on concrete button, and this combination is driven into the ground. After reaching desirable depth, corrugated steel shell is placed in the steel pipe. This shell consists steel plate welded at bottom, and this plate is attached to concrete button using long socket wrench. Finally, the casing is removed and concrete is filled in the shell. This type of piles can be used up to 2-3 MAND for loads up to 50 tons. Sand piles. In this type of piles, holes re-driven into ground to desired depth and sand is filled in the holes. Such piles improve the bearing capacity of the soil. If instead of sand, gravel are used, the piles are called gravel piles. Timber piles. In these type of piles of hard and strong timber pile carries a cast iron shoe, and upper end is provided with a steel plate to receive hammering stress. If a number of timber piles are used, their tops are provided with a concrete cap known as a pile cap. Steel piles. Precast piles and driven cast-in piles make use of steel pipes. In the case of precast or totally performed piles, there are two classifications such as hollow small displacement piles and solid piles. The hollow small displacement piles make use of steel pipes when steel pile foundation is recommended. When it comes to solid piles, steel H piles are used. In the case of driven cast-in-place piles, the main classification is concrete tube steel tube. In case of steel tubes, we make use of closed-ended tube and open-ended tubes. Generally, the steel piles can be classified as screw piles, disc piles, H piles, disc piles, H piles. Rolled steel H-beams performed as a bearing pile is one of the new technology developed in the piling industry. Hard driving of the pile into the soil strata results in large amount of impact forces and stresses. The H-piles can sustain this stress to a large extent. H-piles are mostly used to penetrate an area with rock or any other hard strata. These are generally used in retaining walls. No extra process of jetting, coring, or adopting methods need to use to perform the penetration of H-piles. The small cross-section of the H-piles make the soil displacement process easier. Box piles. These are generally rectangular, square, or octagonal in shape. These consist of deep beams which offer adequate frictional resistance and end resistance. Circular pile. These piles consist of circular steel tubes driven into ground to desired depth. From the open-ended pile, soil is removed and cement concrete is poured. Wrought iron piles. These piles are generally solid and circular, having diameter ranging from 80 to 200 mm. Their normal length is between 4 to 6 meters. These are especially suitable as shafts for screw piles. Composite piles. Composite piles are those piles of two different materials are driven one over the other, so as to enable them to act together to perform the function of a single pile. In such a combination, advantage is taken of the good qualities of both the materials. These prove economical as they permit the utilization of the great corrosion resistance property of one material with the cheapness or strength of the other. The upper and lower portions of composite piles are made up of different material. For example, composite piles may be made of steel and concrete or timber and concrete. Made up of two or more different materials, for example, steel and concrete. For a timber concrete pile, the lower section of the pile might be timber, while upper section might be a concrete or even a steel shell pile. The timber part is installed below groundwater due to its vulnerability to insect attack and decay above ground. The concrete or steel pile is then used above the groundwater level. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.